This conference will now be recorded.
Okay, now let's. So we are going to. We don't directly switch to collections, jump start to collections. But what I want is first we should finish arrays before I get into this. Okay, let me get into the arrays topic now. So after types, I think we had discussed something. What is that? Loose coupling, and then after that, we have this arrays. Probably, if I'm not wrong. So yeah, this was the one. Okay. So what is an array? That is what we need to understand. And when you start learning collections, we generally start with arrays because arrays has a lot of interlink with collections. Even array itself is a collection. We don't need to think we are learning something else. But the difference is arrays are static collections, whereas collections are dynamic collections. We'll discuss. We don't need to know judge it in the starting itself. Once we understand arrays and when we switch to collections, you get exact difference between arrays and collections. Even some of the collections are more like arrays with some dynamic functionality. That's all. Otherwise, the concept of collections is same with arrays and some of the collections, not every collection. Few collections might be different. We don't need to worry about that. So when you talk about array, what is an array? There is so much here, but I'll just quickly tell in my words. Okay, it's simple. So far, what we have done is we used to initialize one value to one variable like this. Suppose in one variable, if you want to store many values, in one variable, if you want to store many value, then we need collections. Sorry, we need array. Even collection is also same. Even there, we use one object. In one object, we store many different objects again. We'll talk about that there. Okay. But now, in one value, in one variable, we can store many values. That is one thing about array. Second thing, this is homogeneous. Homogeneous means we can say like this: an array is a collection of same type of values. Same type of values. That is one. Okay. Second thing, that is what same type in sense. If the array is integer array, all the values in the array are integer values. If it is double array, all the values are double values. And we can call such thing as homogeneous. If in a collection, if all the values are of same type, then we call it as a homogeneous. And if you can have different values in that, like an int value, a float value, double value, and any other object, and if you can have like that, then it's called as what we call it as a heterogeneous. Got it right? And arrays are one of the most used. No, when you talk about arrays even they are most popular constructs in programming. We use a lot of arrays even in programming, like how would we do with the collections. Okay, so that is one thing. Second thing, and as discussed, the definition itself tells everything. Got it right here. And second thing, usually arrays are static in nature. What is that? Arrays are, what is that, sir? Static in nature. That is one more thing. Static means fixed in size. We can just simply say that is it is fixed in size, sir. Means once you declare a size for an array, then memory is allocated for the same size. That's what we call static. So in that way, what we can understand here is it is static in nature. That is fixed in size. Means it is not growable and shrinkable. It is not growable and shrinkable. Suppose if you talk about collections, collections are growable and shrinkable, sir. But arrays are not growable and shrinkable. That's why it is dynamic. Collections are dynamic. Array is static because it cannot increase its size or decrease its size. Once you declare the size, that's it. Maybe you can change the size in the declaration. Once after doing that, in the code, you cannot change the size. That is what we call static. The third, another important point. It is index-based data structures. These are all data structures, sir. If you talk about arrays, you talk about any collection, these are all data structures. Suppose in C language, if you have learned some C language, might be if you don't have an idea, leave it, sir. We are not doing C programming here. You remember some data structures like linked list, colors, stack, queue, something like that. Graphs, trees. Even in collections are nothing but they are just data structures. But they are ready-made for us. The advantage is they are ready-made. And your job is just you need to understand methods and just to apply it. Like that, when you discuss here, these are all data structures. Even array is data structure, and this is indexed data structure. Means what? It has indexing, sir. By default, if you declare an array, you don't need to provide any indexing. By default, it has indexing, sir. And we have to use that index. Whatever you do on an array, you try to read a value from an array, or you try to insert a value into array, or you try to modify a value in array, or you try to delete a value from an array. You do whatever you want. It has to be done only through index. Do you get my point? And one more thing, sir. If you really understand arrays properly, then it's so simple. You feel so much simple with collections. At least there are indexed collections. I'm talking about that. Okay. The basis even for collections, arrays are a basis again. Definitely arrays has a role in collections. Okay. And this is indexed data structure. Performance wise, static data types provides always better performance. They are fast in access. They are very fast. So in that way, when you talk about performance, arrays are best. Arrays provides best performance. Got it right? Like for retrieving data, for inserting data, when you talk about such things, if you ask what performance, you are trying to extract data from an array. Usually, once we load data to array, we add data to array or insert data into array. What we do is most of the time we try to read the data from the array. And when you try to insert data or extract that data, you get that data from the arrays. The performance of that, the speed at which you can insert or the speed at which you can extract is really very much faster. In that way, performance wise also arrays are best fit for. Now, if you want best performance and if you want a collection, and if it is fixed in size, definitely you can choose array. And if you want dynamic, then you have to exclude arrays. Okay, that is one more. Next, you got it right, sir? Next one, another important point here. If you see this, array is collection of mutable values. Means what, sir? Mutable values means, right, which we can modify. Immutable means which we cannot modify. You got it right, sir? So usually we have something which we can modify here. That's what this is saying. Okay. That is one more important point. Already this is discussed. It is indexed data structure. And usually indexing of array always starts with 0 and ends with size minus 1. We'll discuss all this. We don't need to worry too much about it. And one more thing is, if you want, you can apply generics with Scala. Generic means what? Applying some common data type. And this T can be integer, float, or double, or anything. It can accept anything. Okay. Might be if you want to understand more on this, the generic collection. When we move to the collections, I will explain even generic collections. Then you get an idea. For now, I don't think we need to talk about generic arrays. At least for this, for now, until we finish this analysis and arrays. You got it right? All of you are good now. This you can skip for now. Other things are very important to understand. Okay, now types of arrays, sir. How many types of arrays are there? So when you talk about Scala array types, we have two types, sir, single and multi-dimensional. One-dimensional arrays and two-dimensional arrays. Okay, if you talk about one-dimensional, what is it? Array with one index. Okay, one subscript. That's what one-dimensional. Two multi means multi can be of it can have 2 dimensions, 3 dimensions, and that's what we call multi-dimensional array. Following, sir. We'll talk one by one. Let's have a detailed analysis one by one. Now, if you see this, sir, let's talk about one dimension. And this is so simple, sir. It is nothing but array with one subscript. Maybe let me add few more points to this. What is it, sir? Array with the one subscript or index is known as what, sir? 1D array. That is one thing. Second thing, obviously, one more important thing. Arrays are used to store elements in linear order, in sequential order. Got it right, sir? It is used to store elements in sequential and contain continuous memory. Continuous memory means the memory is also allocated continuously. Okay. And that's why we always use index. That is nothing to worry about it. Okay. And we have discussed these points anyhow. Traverse all the elements of an array that you can easily traverse. That's what we have discussed in the beginning. Got it right, sir? This is about the basic introduction to arrays. See, this is all a theory. Maybe you can just only for understanding what is array, how it is useful, and what kind of data structure is it. Okay, that these things are enough. Is it static or dynamic? Okay, that those things are enough for us. Now the syntax part. Let's understand syntax. Let's start doing some programs. Then when you start doing programs, automatically you understand that array thing. Okay, that is not something difficult. And one thing is here everything is an object. Again, arrays are objects. This is Scala, right? Suppose if you go to C language, that's not an object. Even C++, of course, they are objects because we apply new operator. Even in Java also, they are objects, not C++, sorry. Even in Java, arrays are objects. Even in C#, they are objects. Even in Scala, they are objects. And Python don't have arrays, they have lists. That's all. Now, how do you declare 1D arrays? We can declare 1D arrays in different ways, sir. One, we can declare like this. This is just a declaration. We don't have anything inside that. We have to declare where we declare normal variable, just like what, sir? Normal variable, just var name and then data type and then we initialize value. But for array, you can see, sir, you should use a parenthesis, even the square bracket. This is called subscript or index. We should apply an index with array, and inside that you should specify. You should declare the type. What type of value you are going to store into this array? Is it an integer? Is it a decimal? Is it a float? What you want to store into this array? That you should declare, sir. That you should specify. After that, you should create an object for array, because now you know we have done too much of objects and classes. When you say new space something, means definitely this is an object. Means what? The left side part is a reference, the right side is an object. And even this index has to be there even at the right side of assignment, right side of object. You can see here. Usually if it is object, what do? We take parenthesis and then we declare object. But here, if you see, first we declare that type in the square brackets. After that, in the parenthesis, we specify the size. Observe this carefully. You get my point, sir? Well, this is as simple as this, sir. This is nothing difficult to understand. Just var space some a colon. Array has to be there because it is a class which we use here in Scala. And then suppose you want integer value, just mention int here and then new array, and then again int has to be there at right side as well. And then how many elements you want to this array? Suppose I just want 5 elements, just I should declare it like this. No need of semicolon. This is Scala. If you want, you can add semicolon. Something. Okay, that's fine, sir. This is just a declaration. Now what happens when you do this? An empty array is created with the 5 locations. That's what happens here. We'll discuss point by point. This is type 1 declaration, sir. If you see, this is type 1. We can declare array in different ways, but probably most of the time we use this last one. But the point is what? Just we are getting quick idea, like in how many ways we can declare array. This is type 1 declaration, where you declare array name and type at the right side as well, and then size. Type 2 declaration, you can ignore type, right, sir? This type is not necessary, because type 2 declaration. This is type 1. When you see this can be treated as type 1. And this can be treated as what? Type 2. Okay. Now when you look at type 2, sir, you know this. If I don't declare array, still the type is implicitly declared by the Scala interpreter or Scala compiler itself. So this is type 2, where you can ignore this data type with this reference variable. But right side part is as usual, it is same. We don't see big difference at the right side. That is type 2. Means what? The same declaration. What is that? Example for this is you can avoid type declaration. Type 3. When you look at type 3, what's happening here? At the right side, you can ignore again type. You can see this is type 3. See, every time we don't use all this, sir. Only just this is introduction. We are discussing different types. Later on, whichever is comfortable, you use that, sir. There is no issue. Nobody is going to force us. It's up to us, sir. You can choose whichever you want. Okay, now type 3 means, now by looking at the type itself, that syntax itself, you understand, sir. Right side here, we are missing this type here. Right side, type is removed. It is ignored. So that is another type. We can still have such declaration as well. Okay, that is one more, sir. What is it? This is one more. Here at the right side, you might give the type, but at the at the left side, you might give the type, and at the right side, you can ignore the type. You can remove the type. Still, this is valid. If you want, you can test all this. Okay, we will test it just for no, testing purpose. We'll test once. Okay. And the last one, probably most of the time we prefer this because this is more handy for us and this is more ready-made for us, and we can easily directly declare an array and continue our process. Usually in Spark, we depend more on this kind of type. Okay, but I don't say that the others are useless. If required, we can use them as well. Okay, sir, if you see, this is so simple. You can ignore if you want. You can even declare type here. That is optional. Scala is dynamically typed and statically typed. What you want is up to you. If you want data type, put it. If you don't want, ignore it. It's up to you. If you want better readability, put data type. If you don't want to take that thing, you can ignore it. Probably if you ask me in the code what I'm seeing in our projects, I don't seriously see people using data type with the variables in our project, because as they know that when you have implicitly Scala declares the data type, so they have given that opportunity to the compiler itself. Okay, Scala compiler, you take this. That's what I have seen in our Scala code. And even when we are developing also, we follow the same. Second thing, I have seen type with methods. When you pass it as parameters, definitely at such times I have seen people declaring types because there it's mandatory. You don't have a choice, right? But in most of the cases, I didn't see people declaring type. But if it is me, I will definitely declare type because I prefer it. As you know, when somebody look at that code, it increases the readability. That's what I believe. But personally, while working in the project, because it is developed by some other developer, so I cannot comment on that thing, because when he is developing code, we don't know what kind of requirement he has, and what made him not to declare data types. There might be some reasons, and he might be correct in that situation. We cannot blame anyone here. Okay? But I'm just giving you an idea so that you get a bigger picture. Right? So that's about this. Okay, for this example is so simple. For that example, var space some a equal to array of 1, 2, 3, something like this. This is type 4 declaration. We are done, sir. Now we need to understand internal representation of array. However, you declare array, you use type 1, type 2, type 3, type 4. However, you declare it. One thing we should understand is array is indexed data structure. What is it, sir? It is indexed data structure. Okay, sir. So now, what is that? Let me just tell you. By looking at this example itself, we can understand the indexing. You have how many values here? 4. Now, like in other types, we have opportunity to specify the size. But here I didn't specify the size, but still it's fine. Here, the size of this array depends on number of values you pass here. If you pass 4, that is the size of this array. If you pass 5 elements, the size becomes 5. Now when you construct an array like this, by default this has an indexing, and it starts with 0, 1, 2, 3. Got it right, sir? That has an indexing, sir. That array has indexing, that object. This object is created like this, sir. This is your array object. It's constructed like this. And I have 4 elements. If you see, we have 4 elements, 1, 2, and 3 and 4. Okay. Now this has an indexing. This is 0, 1, 1, 2. Okay, or you can assume this as a of 0. You can also call it as what, sir? A of 0. This is A of 1. The array name is same, sir. But what changes here? Index changes. So whenever you insert into array, you extract an element for an array, or you modify an element of an array, or if you want to set it to some default values, what we call nullifying technically, excuse me, then what in all these CRUD operations, like what we do for databases. CRUD means, right? Create, retrieve, update, delete. Okay, like that. Here also, if you perform any of this, we do that with index. Okay, we see with the example. Now, this whole object has one address, and this address is assigned to this reference. Suppose you see this is A is the reference, and this is holding this address, and now A is pointing to this object. If I want any element from this array, then how do I extract elements? See, these are two ways. I'll just give it simple and quick syntax where we don't need to confuse it here. Suppose if I want to assign value, the syntax, how to insert or update. If you want to insert or update, the process is same. Just it's like that var name of that index equal to value. This is for update. How to extract, how to read element for array. Element from array. So the same thing is applicable even for collections also. Suppose you start, working with list or vector, or there are indexed sequences. There are many other collection classes. Even when you handle those collections, the way we update them or the way we extract values them, almost it will be almost similar. Got it right? I told you, right? If you can master arrays, then you are much more comfortable with the things. You don't feel they are really a different topic. That's the point. How to read element from array means simply the syntax is like this. Just var name of some index. For example, here A of 0 equal to 10. Here, just A of 0, like this. Okay, this is simple idea about arrays. Okay, how to declare, how to initialize. Suppose if it is the type 2, type 1, type 3, it will just create an array. Then you have to you have to explicitly keep adding elements to the array one by one. Sequentially, you should add elements to the array. Okay, you can try both the cases here. You can choose both the cases. Suppose you see here for one example, and now right, you got an idea, right, how the indexing is same for any type of declaration, whether it is type 1, type 2, type 3, or type 4. Once you declare the size, based on the size, array is created. Suppose if you say size is 5, you have 5 locations in the array, and index starts from 0, ends with size -1. If size is 5, it starts with 0 and ends with 4. Got it right, sir? So let's see some examples, sir. Let's jump to the programs. Here we can work as many programs as we like, sir, because arrays is also, we can play with so many examples. And even there are so many very useful things we will discuss with arrays as well. Something connected to your real use cases as well. So now I am taking type 1 declaration. Okay, a quick idea for all of you. Okay? After that, you can take some assignments and you can start working. Suppose you see, sir, let's take this type 1 or type 2, anything is fine. So you come here, just put it. Now right, the size of array is 5. Now what you have to do? Now you have to insert elements to the array and you need to print it. Got it right, sir? So how do I insert? I can directly say this is static initialization. I have 0 equal to 1. Then here we use parentheses, sir. Suppose if it is Java, we use square brackets. And in most of the languages, we use square brackets. But only Scala uses parentheses as index. And this is what you have. Now what did I do, sir? Now when I declare this, at this line, array is created with 5 empty locations. Now what I am doing now? I am assigning values to each location. Okay, sir? Like this, I have 0 equal to like this. This is static initialization. If you want, you can read from keyboard as well. For that, we use this scanner and input functions. If you want, I'll show you one example for that as well. Because we didn't use the scanner so far. And that is not something difficult as well. Because at a professional level, it's very rare that we input values from keyboard and we print values onto console. Even if you put prints for testing at our development level, when you move it to the production, all of us know that we have to remove all these junk codes. We have to clean it up. I hope you know that. So now you need to print all this. Print ln of a of 0, then print ln of a of 1, a of 2, a of 3, a of 4. Don't try to print a of 5, sir. Why? A of 5 is not there. That location is not there. And if you try to print something which is not existing in an array, if that index is not there, it leads to array index out of bounds exception. We'll see one by one. This is a simple example. Usually we don't initialize each location, we don't print each location set. We depend more on loops here, probably for loop or while loop. Okay, mostly we depend more on for each. Okay, that's what we use here. As just this is an introduction, just I'm giving you a quick analysis on all this. Okay, so just run it. Now you got all the 5 values. Out of your curiosity, if you try to print an element from 5th location, you don't have any issue at compilation. But when you run it, the JVM will give left and right for us. If you see here, what is it? Array index out of bounds exception. And that is told to. We had concluded that. We discussed that. So point is, these exceptions are, we have to keep an eye on these exceptions. That is very important. When do you know that you are missing out something? When you know that this index is, you are giving wrong index and which is not there. When you know that fundamental clearly, then we can easily fix this kind of issues. But these are quite frequent exceptions that we see in a real code, real time code. This array index out of bounds exceptions, null pointer exceptions, okay, casting exceptions. Like this, there are some common exceptions which always we keep seeing them. Okay, that is one of most popular exceptions is that this is array index out of bounds exceptions. So that's about this one, sir. Suppose if you give size as 10, we have 10 locations, and you don't need to use all 10, sir. If you want, you can just use only 5 and keep the remaining 5 as is. You can just leave out the remaining 5. And right, sir, did I initialize values to 5th location? Now if you see here 4, now I am printing remaining locations also. You should see something interesting here. Okay, you might be wondering what happened to this guy Manohar. There is no elements in the array. How he is able to print it? Why he is printing? You might be thinking. But the point is, once you declare an array is an object. By default, this array is initialized with the default values. Suppose You didn't initialize anything to this array, sir. See here, I commented the initialization here. You didn't assign anything to the array, and straight away you are trying to print the values, sir. Straight away you are trying to print the values. Now let me run this, sir. Did I get any error here? No. But what I am seeing here, the default values. I told you somewhere at some point we had discussed default values. What is default value of integers are 0. Default value of decimals 0.0. Default value of boolean false. Default value of character space. Anything else, sir? So these are the most used default values. And for objects it is null. For string or any other reference type it is null. So this is another important point. Once you declare an array, once you construct an array object, and even though you don't assign anything to that array, by default that object has default values. Now what you are doing then after that, you are simply overwriting those values with new values. You are reassigning them. That's why they told array is a mutable, array has mutable values. You got this point, sir? Another important point. Okay. Likewise, suppose if you create a decimal or double array, sir, or float array, by default they have 0.0. Okay. Similarly, if you create a boolean array, by default all that locations are set with false. Following, sir. This is idea about what is that, sir? Idea about a 1D array. Quick idea. Now what you can do is now you got an idea about how to declare it, how to initialize it, how to print it. Right, sir? And also, more than this, generally we prefer to use this, sir, because this is all usually in a real environment. More than this, sir. And in few cases we prefer this, declaring with size and doing all this. But usually we prefer this approach. Is that something like array and then 1, 2, 3, 4, 5. Now it's easy, right? Once you initialize elements for an array, okay, sir, once you initialize elements for an array like this is type 4 declaration. Okay, instead of printing each value from one location, better use loops, sir. Go for iterating these arrays, apply iterators. The iterator, the best fit iterator here is for each. So what I can do for, you remember loops, right, sir? We have done so many programs on loops for I, okay, and then A. From I, for each element of I in A, what you are doing, try to print it, println of I. You should print I, sir. Now run this, and if you see there, you got the output. And this is the best practice we apply in a real project. We don't print element, index by index, or we don't assign index by index. But what do? We do it with loops. We assign array with the looping, and we print elements by looping. Usually we don't print it, sir. We do some kind of data processing. That's all we do. Understand, sir? We don't print it, but we do data processing. If at all, if you want to do anything, we assign that data to the logs. Suppose if you want to see something in the output on the server screen, because when you run, we run it on a server screen, okay, connected to the server. Then what happens, sir? If that is the case, what happens, sir? We log it, and that logged information we can see on that server console. Got it, right? That's what we do in a real environment. We apply logs. We don't apply prints. Got it, right? But here, as we are in the learning state, we are trying to apply prints. Even we can try that here also. Applying, that logs is not something really, difficult or something complex. Even we can try here. We will take that use cases. Once I finish this Scala Spark, we'll do some scenarios which belongs to a real-time project. Got it, right? That projects are common for any project, not just only for our project. There are any project will follow the same kind of process that we'll discuss. Okay. Now we are done with this, sir. So what I want is first the basic program, because some of you might be new to the programming. What I want is I want you to test it quickly once. Okay, please test it once. Then we'll see the this is type 1. Now you can follow type 2 or type 3. It's up to you, sir. You can test with all the different types. Then after that we will see type 4. Then we'll start doing some tasks. I'll give some tasks. Let's see. You try to work on that. If not, I will give the solutions. Mostly in a real time, we use 1D arrays more than 2D or 3D. 3D is almost ruled out. It's very rare. Only in scientific projects people might use 3D arrays, and even 2D arrays. That's very rare. People use 2D arrays because most of the time, starting from Java till this, your big data, I never seen using 2D arrays. I didn't see it. But 1D arrays I have seen lot of times. Please test it, sir. Take a minute and test it, just for getting some quick understanding, clear understanding. Probably we'll start Spark weekend, sir. Hope you are comfortable, right? So that we can parallelly start doing the other very important area of big data. Are you people comfortable on weekends?
Manohar, this Bharat,
Yeah,
can we have
please.
this Spark session, evening session or something, not in the morning time?
Yeah, no problem. We will plan according to that. We will definitely plan as per the convenience of you people, because no, you are the one who are always there, no, and following it regularly. So at your convenience, we will plan the sessions. No issues. Okay.
Yeah. Thank you, Manohar.
We'll see, like, what is the common time all of you are comfortable in the evenings. Weekends only. That's what Spark we are planning weekends. But what time is it that we have to think? After 6 p.m. No issues. That we will plan like when to. But even on weekends we'll just do only 1 hour, not like 2 to 3 hours like that, because 1 hour is enough, sir. So that even I have that energy and you have that interest. Long hours means not sure. So if the topic is interesting, and if you have having patience, and if I have energy, we'll continue after 1 hour. But let's keep it for 1 hour every Saturday and Sunday. Probably we will do it from next week, not this week. This week we'll finish off Python. Yeah, we will check with everyone, and based on that we will plan. Okay, the time, whether it is from 5 to 6, 4 to 5, whatever it is comfortable, we'll plan. Is it finished, sir? Testing of this is done. Okay, next one. You test this scenario also, sir. Another scenario is this. What is that? This one is that array with direct initialization. Then we can apply a for loop here to iterate. And then here you have to say a of I, sir. And then run the program. And somewhere I'm seeing an error. What is the error? Array of 1, 2, 3, 4, 5. Okay. The error is this. Remove this new operator. You know, right, sir? When I put new, you are getting an error. One thing is this, behind this, you have a companion object. Do you guess this? Did you guess this? We are not instantiating, but that is a class. Array is a class, sir. But we are not creating object for that. And you can see apply there. Apply is coming there. Can you see there? Behind this, what is this? We have a companion object. We had a very detailed session on that. You remember, right? Okay. So let's run this. Index out of bounds exception. 1 minute. I should not say a of I here because already we are iterating element by element. I itself has the value. Here we don't need to specify the index. Index is not necessary because it's a iterator. It will iterate on this array. When you pass array as no, source, what it will do? This will extract element by element. It will iterate for 5 times. Every time it iterates, one value from that array is extracted and put it into this I, and that we have to print. So that's my mistake. But now the issue is closed. Okay, sir, got it right? You can test this also, sir. Then I'll give we'll do some tasks on arrays. Is it done, sir? Completed? Okay, we do one thing. Please take one task here. Write a program. Already we have some methods, of course. Method thing we can do it later, not an issue. Write a program to find. This is the task, sir. Let's see how far you remember your logics. Write a program to find sum of elements of an array. Sometimes these logics keep coming, sir. Please test it, sir. Please try this. Is it done, sir? All of you? I'll just show you. See, this is simple. You can see here, I just ask the sum of elements of an array. We have done this many times. Only thing is, we are doing sum of elements of array. Earlier, we have done sum of numbers from 1 to 10 like that with just loops. You just need to declare one variable where sum into then for okay, less than a, yeah, less than a, sum equal to sum plus a of a, sir. That's all. This is the logic you have to do, sir. Very simple logic. And finally, after that, just simply say println of a sum. We are done, sir. This is simple idea about printing sum of numbers of an array. Of course, again, this new is something I should remove, sir. That's the error. Nothing more at all. What they have done is inside the API, they made sure that when you create array object, the developer not to use that new operator. They have applied some filter on that when they create some companion for this in the background. So we are done, sir. 1 to 1 plus 2 plus 3 plus 4 plus 5. Probably it should get 15, I hope, sir. Okay. Again, the same mistake I am doing. It should be simply sum equal to sum plus I, sir. Not sum plus A of I. Now we are perfect here. Got it right, sir? This was finding sum of numbers from, what is it, sir? Sum of elements of an array. Please test it, sir. If anybody needs to test it, please test it. So tomorrow, there is so much with this, sir. We can also see how to create array for reference type as well, like array of objects, like array of students, like array of customers, array of cars. How do we do that? These are all, these scenarios definitely depicts in your real-time scenarios. Whatever we do here, definitely this will be useful for you when you are working in a real project. Okay, the syntax thing anyhow, people will discuss in many videos, or there are there in many websites, and only in few cases we get something which is really necessary, which is there in the project. Okay, so this is simple idea, sir. Introduction and a few examples and arrays. Okay, tomorrow we'll continue, sir. We keep doing this, then we will understand arrays properly first. That is very important, because if you can play arrays properly, then it is much more easier for us with collections. Trust me. You got it right, sir. So that's it, sir. Okay. So we are going to stop here because we have another call today. Thank you.